Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at, programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay.
So, what's the benefit of doing all these quotes versus just redefining the curried lambda that supports it sort of more natively, that we don't have to deal with all these quotes?
Okay, so your question is, why have curry?
No. So right now we have a lambda object, and you're sort of building curry on top of it. What if we just create a new lambda that supports currying more naturally, sort of saves these curryings in Java, saves them independently without all the quotes? Like you just save them.
So you're saying just don't do the quotes and have something special, a curry lambda.
Effectively, yeah. You would have to extend lambda and create a purposely built lambda.
So it's more uniform this way. You don't have to understand a new concept. Okay. We could have done a function too, I believe. Okay, unless I've implemented it, I don't want to ever say for sure. But we could have done a function too, but and that might have been a better solution than either the quoted thing. And I'm going to ask Andrew why he didn't do the function. I'm interpreting why he didn't do the function was to sort of capture the values at defining time, so that it behaves differently from function. But we could have done a function lambda also. Okay. I've been wanting to give you guys Defun for so long, and we never get to it. And maybe we'll finish it today. Okay. So you guys have used Defun in C-LISP. We don't know how to implement Defun, and the fact that I'm doing it so late means that I kind of care less about Defun than I care about other concepts. So we'll see whether I'm justified today or not. So Defun is also going to be extra credit. Okay. Part of the reason I'm doing all this extra credit is, you guys get the satisfaction of having done a project that worked over the whole semester. You have the handicap that, problems from A1 go to A2, problems from A2 go to A3. So to reward you for having reached this point, I'm giving you all these things you can add very easily and get extra credit for that. Okay, so that's sort of my thinking. Also to sort of make sure that those of you who didn't get the credit, the points you deserved in your midterm can make up for this. Okay, so Defun is also going to be extra credit. Okay, so we've seen that how SETQ is used, how Defun is used. So you want to try to, anybody want to sort of summarize the differences between Defun and regular call versus SETQ and FUNCALL? What abstractly are the differences? I mean, sure, one uses the word Defun, one uses the word SETQ, but conceptually, what are the differences? And you're seeing the syntax in front of you. What are the semantic differences?
So the function name is legal in the S expression to start with.
You can start the function. That's legal. So suddenly that semantically, your S expression evaluation has to change now. It has to allow for something to be defined, right? Okay, that's so you don't need FUNCALL. In fact, you can't do FUNCALL with a Defun variable. Okay. So in C-LISP, by the way, I'm using C-LISP here. In C-LISP, when you do lambda, lambda translates to function lambda. So you really don't get lambda directly. So that's what you see here. That when I did SETQ f this, I got back the FUNCALL. I got back the function. When I did a Defun f, I just got back the name f. So there's some difference here already. In one case I did FUNCALL, the other case I did just f12. Okay? So, okay, let's see some more things. If I go and type f at this point on the right-hand side, what do you expect? Sorry? Not enough parameters. But I haven't put f in parentheses. I've just put defined f. I've just put input f. And you know, who knows what it should really do? We are trying to be language designers here. What else could we get? One is that we could say, hey, you haven't put f in a function called bad. What else could we do at this point? You could perhaps print the definition, and that has to be an S expression, right? Can you imagine printing that information as part of something we already know? Not so, what the question is, so you want to know the definition. What kind of object, what kind of S expression should that value be? A new S expression or something we've already seen before? And I'm trying to hint at the latter. Okay, so defun is going to create automatically a lambda embedded in a function. You don't have to type lambda, you don't have to type function. Just as you didn't have to type function on the left to get a function, here you don't have to type the lambda either, and you get a function. Okay? So automatic construction of function lambda from defun definition. Okay. What happened to my animation here? Okay, so my animations have got wonky here. Let's go and see the left-hand side. If I go and do SETQ F4 on the left, and I type, I get back. I mean, this is legal. You guys have probably seen this, or you haven't seen it. That's legal, right? You can redefine F to be anything. I get back 4. Natural. And if I do funcall F12, what should happen at this point? Okay. Right? What if I do setq f lambda x, setq f to a lambda expression now? Okay. We get back a function x, you know, we get back, we are allowing redefinition, it seems. If I do funcall F1, this should be legal. What if I do F12 at this point? Sorry? It's legal. It's legal to call F.
They're different. They're different.
So this is confusing. Based on what I saw with SETQ. Okay, so let's. So how many of you think it should be 3 at this point? And how many of you think 3? How many of you think it should be an error at this point? It's confusing. So, yeah. So what's the moral? Defun references a function-only namespace. SETQ references a data and function namespace. So on the left-hand side, you know, there was a namespace that included both the data and the function. And when you assigned a new data value, the function value got erased. If you guys notice in your environment, there's lookup fun, assign fun, which have just all these vestigial things that, you know, didn't have any purpose. Now they'll have a purpose. Because defun will go into that namespace and not the other namespace. So is that a profound idea? I don't think so. But it is something in C-LISP. That's why I postponed defun definition till the end. Okay? And so, well, we still have 4 minutes left, so maybe we can actually make more progress on this. But you guys get the idea? It's a different namespace. So way back, we had get, put, lookup, and assign. That was the namespace used for SETQ. And now we have, and I promised you very early on that we'll define another namespace later. Okay, now is the time. And we have get fun, put fun, lookup fun, and assign fun. And defuns go there on the left. Defun things go in that namespace. Okay, it's just a detail. It's a detail that I might have learned at some point in my life when I learned Lisp, but I had totally forgotten it. So I had to relearn it. Okay, so I think that's not very intuitive. So if we want to do a defun evaluator in 4 minutes, it's good if we have seen something similar before. So what have we seen before that can be used to inform our implementation of the defun evaluator? SETQ. And what else? Okay, so 2 things. Function and SETQ. Okay, defun is combining both function, the function operator, and SETQ together. And we just have to go and take these steps and combine them together essentially. Okay, so because we have to create a function definition, so we have the same information, and with that information, we have the information we need to create the lambda, and from that lambda, we have the information to create the function. Okay, so we use the same, the information is presented in a different way, but we have that information, and once we've created the lambda, we have to go and assign, once we've created the function, we have to go and do assign fun now, rather than assign, and we associate f with the function we got. Okay, so when we did function, without the keyword, when we did function, we had in front of us both the function keyword and the lambda keywords. Here we have neither. Okay, and that's okay. We have the information that we have to go and pass to the factories of function and lambda, so we pass that. Okay. Questions? And we have to also go and, so what else do we have to change? Remember that when we typed f, we would get back the lambda, we get back the function definition. So now when we go and evaluate A, and if A is a variable environment, we used to, if it's a variable atom, we used to just do eval of the environment, the eval of the, A.eval was returning environment.lookup A. Now what should it do? Sorry? So we have 2 scopes to look up. And in what order we do that, who knows what the right answer is. Okay? But we have to go and, let's go and say we go and first look it up in the environment, do a lookup, and the lookup fails. It does not fail, we return that value. Otherwise, we do a lookup fun.
Does that imply you can set Q a variable to define?
That's what we did in the previous slides. We had f defined to both.
I don't know, but like I could do set Q G F. With G being totally new. But like G is now in the set Q namespace, and there's something from the defun namespace in the set Q namespace.
Yes. That implies that. Okay? Okay, and okay, so you guys are getting ANSI here, and we'll finish it next time. But this will be one of the extra credits in your A4. Okay. Okay, so that's that. We talked of currying, and then we talked of freezing environments, and we talked of in function definitions. And another thing we looked at last time was defun, and we did more or less defun completely, but we left some things, so let's go and complete those. And actually, I made a mistake compared to what C-LISP does, so I want to sort of clarify that point also. So let me remind you guys again, difference between defun and SETQ, which you kind of know from having used it. Use both. The one subtle point that some of you may not have known is that you can SETQ and defun the same identifier, and that doesn't cause any issues, because if you SETQ'd an identifier, when you call the function, you say FUNCALL identifier, you don't just say identifier arguments. Okay? With defun, you go and just supply the arguments, you use the function directly. So right now I've got two definitions of f, and when I say FUNCALL f1, I get 1, and when I say f12, I get 3, because they're two different functions. And if I do FUNCALL f12, it expects f to be a SETQ'd variable, so it gives you error about number of arguments. Okay, and if I just type f, it evaluates it looks up the variable space and gives you the value bound to the variable. Okay, so this is how. So there was some subtlety here about how SETQ and defun relate to each other. Okay, questions about this? So where I made a quote-unquote mistake was I said, what should happen if we have a defuned variable and I just type the variable, and I asked you guys, and Chris said, look, just go and give what the definition here is. I said, why give the definition? We know we're going to store a function, so why not just display the function? And I didn't even check. I was so sure that's what the answer would be. And as it turns out, you get error variable has no value. Okay? And that implies that when we type f and f is defuned, it doesn't do a lookup in the function space. Okay? To evaluate. Whether it's good or not, we can sort of leave that as a value judgment for now, but that's what happens. If I say quote f, I just get back the atom as I would get with any quote, so that's not a problem. If I say FUNCALL f12, okay, as I said last time, we'll get error variable has no value, but if I do FUNCALL quote f12, I get 3. Okay. Now these are mostly details that are uninteresting to me, because there's a lot of arbitrariness here. But this is stuff in C-LISP. This is stuff that you can implement with not much more pain. So this is stuff you can do as extra credit. So that's why I'm bringing it here. Okay. And if I do SETQ G quote f, okay, I get f. Right, because that's what quote f is. But if I do FUNCALL G12, okay, we'll evaluate G and then go and look up the function call. Okay, so this will work. Okay, it may or may not be intuitive, but this is the semantics. Okay? Okay, so let's go and see how to implement this, and we'll also try to figure out why C-LISP does it the way it does. And there's many versions of Lisp. So this, I'm just talking the C-LISP we get. To implement defun, we saw that we needed not only get and put and look up and assign, but get fun, put fun, look up a fun, and assign fun. Okay, two different namespaces. We saw that last time. We also saw that we have a defun evaluator that basically combines together features of SETQ and function evaluators. Okay, and the only thing I want to highlight at this point is that I said, in last time I said we return back the function that's assigned to f. When we do a defun evaluator, as it turns out, we return the atom f. Okay, so that's what we saw, that we don't actually return the function value. We don't evaluate things that are defuned when we return them. Okay, so this is what we did last time. And we could do something smarter here, which is sort of like copy on evaluate. If we know that that lambda has no free variables, then we needn't create a function. We can just assign a lambda to f. Okay. With SETQ, we have a choice. We can assign to a SETQ variable either a lambda or a function. So if we are encompassing that in a function, we must have a good reason to do so. So presumably there are free variables. But with Defun, we don't say lambda or function, and the system just assumes it's a function because you just want to give you a function behavior. But we can be efficient, and I'm not saying you guys do this. I'm just saying in general we can. That we could just assign lambda to f. Again, if we assign lambda to f, some of our evaluations change, but I just wanted you to keep this in mind. Okay. So let's go and see. This is where we ended last time. And I said, look, what we had was that if A is a variable atom, we did a lookup in the environment, and that was the value returned. And at that point, I thought that what LISP would be doing is what I have on the right, that it would first check if it's a variable atom. If it's a variable atom, it would first check if it's a SETQ variable. If so, it would give precedence to SETQ variable and return that value. Otherwise, it would go and check if it's a defined variable and return that value. Those are the semantics I was assuming when I last presented this. But this is not what LISP does. And now can we try to justify from a language designer point of view why LISP is taking at least the one that in the implementation you have is taking, or what are the pros and cons? So the one on the right is what Chris intuitively believed would happen. That's what I intuitively believe would happen, and maybe some of you intuitively thought would happen. So what would be the argument for doing what's on the left? That means, not evaluating defined variables. So in general, when somebody designs, makes a decision, we have to guess what they were thinking. It's like Shakespeare. Everybody interprets what Shakespeare said. They didn't explicitly say, this is why I said this. Okay. So in general, if the atom, so we know that this is, by the way, this is the example we had where when we typed f, it said variable f has no value. So in general, if A has been bound to in both the variable space and the function space, then there's an ambiguity as to what the value should be. Ambiguous stuff causes confusion. Okay, that's like in multiple inheritance. You go and inherit from two different classes, they both have a toString method. Which one should we choose? You can say, well, the one, if you're going and extending two classes, you put one class name before the other class name. So we will give precedence to the one that appears first. There's a lot of language designers that have gone that way. If you import two classes, one from package A and one from package B, so you have import A.C and B.C, which C is imported? Some languages said, hey, just look at the order and choose either the first one first because it came first, or the last one because it overrode the first one. So it caused confusion. So the argument for not doing it, or at least an argument, is that let's just avoid this ambiguity. Okay. But, there are languages that support multiple inheritance. There are languages that go one way or the other. And so I'm not saying one is better than the other. Okay. So giving precedence to variable space can be confusing. Okay. We haven't quite finished Defun. We still have to go and now change our expression evaluating routine. Okay, so far expression evaluating routine said that look, F is an identifier atom, and if it is an identifier atom, then it better be a basic function, or F is a lambda expression, or F is a function expression. Okay, so F could be FUNCALL, it could be SETQ, or it could be a lambda expression or a function expression. And now we have another case where F is the Defun function. Okay, so we have to now change this part also And so we're going to just call something called defun helper.eval. And again, there's nothing profound that's going to be different here. So we already have a funcall f e1 e2 en. And now something similar we're going to try to do. We're going to say s is equal to f e1 to en, where f is now a defun function. And so I thought there was, okay. So we go and just do look up fun, okay, and after that, what kind of value will f eval be when you look it up? A function. And we already know how to deal with functions, right here. Okay. So we could just go and call this code that we have earlier. Okay. Now, if we've done okay, we could also do the following. We could do the lookup and say, hey, let's just go to this part here and check whether it's a lambda or a function. Okay, because as I said earlier, that we could have a smart helper, a smart defun that goes and stores a lambda if there is no free variables. So we could just go and actually jump to this particular piece of the code and expect a lambda or a function, and then do exactly what we did before with the Funcall code that we had, that either go the lambda route or the function route. Okay, let's look at Funcall itself. Do we need to change that? And we wouldn't, except that we allow this kind of semantics. We allow Funcall code f12. Okay, so we allow Funcalls on Funcall to access the defun definition. And by the way, this is something else you can do in C-LISP. You can say func code plus 12. You can't do func call plus 12 because when plus evaluates, it won't evaluate to any lambda. But you can say func call code plus 12 and get 3. And this would be nice because we can then do something like this, where display takes a function as an argument, and we can send it a code plus, and that should work, because a func call on code on that would work. Okay. So in your assignment 3, you had to go and define some, and you had to define some. You had to take some basic functions and define lambda expressions for them. With these semantics, you don't have to do it. Okay. So how do we handle quoted non-variables? Or should I? Yeah, non-variable meaning it's not stored in the SETQ space. So how should we change? We have the funcall on the left. How should we change the funcall on the left to accommodate this? Yeah.
Would we make a new S expression, evaling that, and then eval the S expression we made?
Exactly. Pretty much. Okay. So we would go and evaluate. First, we would go and evaluate the function. And at this point, if it is at this point, we've got to either go and take this route, or we have to do something what Andrew mentioned. And we know it's one or the other based on whether f-eval is an identifier atom or not. Okay, if it is a regular lambda, if it's a lambda or a function, we would get back a lambda object or a function object. Okay, but if it happens to be an identifier atom, okay, then essentially we do what Andrew said: make a new S expression and evaluate that with the evaled identifier. Okay, otherwise we just do what we did earlier. Questions? Okay, so we saw that. So let's go and this is something that Andrew Wittkus invented. This curry thing, like I said, doesn't exist. It isn't C-LISP. Okay, so the way we defined curry was that we did SETQ, and we said SETQ variable name curried and assigned to that a curried expression. Okay, and when we did it that way, we had to do FUNCALL on that SETQ variable. Okay, it might be nice that you don't, and this again brings it in more in line with ML. It might be nice to have a DefCurry, which is like SETQ, except that we can just go and name the variable function directly. We don't have to do a FUNCALL. Okay, so that's another thing you can add. Okay, as an extracurricular thing, and we have the curry implementation. So how would DefCurry be different? So DefCurry now takes the function that's being in the new function name, the old function, and the arguments applied to the old function to create the new function. So we have curry, and what should we do with and DefCurry would do what? The difference between DefCurry and curry is? Or how would you define DefCurry in terms of the old curry? Okay, so do what you would do in curry. Okay, evaluate that part. Okay, and so this is a subtle point here. You're supposed to associate functions with in Defun. So you would create a function and then assign that function. Okay, and the subtle part is that do we really need a function here? Function is used to make sure that the free variables are looked up in the defining environment. The way we've implemented curry, we already go and evaluate the environments. We go and evaluate the arguments and store the quoted result. So lambda has no free variables, and I could just go and store the lambda as long as my defun, my other code allows defun functions to be associated with lambdas. Okay, so I talked about a flexible defun helper. So this relies on the flexible defun helper. Okay. But the way Andrew did it was the previous way. He just stored a function. But this should also work. Okay. Okay.